Dimensional analysis is a way to convert from one unit to another without changing the value, but it's also a way to practice and get really comfortable with keeping track of units, which will help us with our math in a lot of different aspects of science. So let's start with a quick math review. We're just going to multiply some fractions. How do I multiply 1/3 by 1/2?
You can cross.
We're not cross multiplying, no. That would be if this were an equal sign.
Oh.
We might opt to cross multiply to solve something. But how do I just multiply two fractions? Yeah, Claire.
Don't you multiply the top and then you multiply the bottom?
Yeah. So we multiply across the top, like that, and multiply across the bottom, so we get 1/6, and it revealed my next one. But I don't want to do that just yet. So pretty straightforward, just multiply across the top, multiply across the bottom. What about this one? Is there anything that any tricks I can use to make this a little easier? Yes, Claire again?
You can reduce 2 to 1 and 14 to 7.
How come?
Because they can go into each other.
Because they have a common factor. Yep, namely 2. So since there's a 2 here and a 2 there, I can divide both of them by 2, just replacing whatever I get. They don't go away. They're still there. And then when I multiply them, it's a bit easier. 1 times 11, 3 times 7 is 21. And we're practicing fractions here, just as a reminder though, of course, anytime you answer something in this class, you'd have to divide those numbers out and get a decimal. So you divide 11 by 21, and that would be a little over 1/2, 0.5 something. What about that one? Yes. Divide out the 2's again, yep. So I'm just going to cross these out, realizing that they're replaced with a 1, so they don't disappear, they don't go to 0, just as a shorthand, and I get 1/7. Okay. What about this? What do we get when we multiply 1/3 by 2/2? What's 2/2? 1. What's 1 times anything? Same thing. It's just a different way to write 1, right? So I still get 1/3. What about 2/3 times 11/11? It's okay to say stuff out loud. This is 1? I know you're thinking, right? Yeah, okay. Just 2/3. That part is 1, so it equals 2/3. Okay, and 7/7. Okay, we see the pattern, right? 7/7, that's equal to 1. So we get just 1/2. It brings us to one of our important rules that we're going to be applying. That multiplying a fraction, you can always multiply by 1 without changing a number's value. So this is an important thing to highlight in your notes. Just as a reminder, I know we all know that, but as a reminder of the rules we're going to be using. Let's look at our next one. Okay, I'm going to have you multiply these out quick and then help me out. Is there anything you note right away about this one? Okay, so what can we do to help us with this? If we multiply these across, we get 1x times 1, which would be 1x, over 3 times 2x, which would be 6x. What do we do with the x's? we cross them out again because it's the same on the top and bottom. Just like when we had a number in there, they cancel each other. So that ends up being 1/6, just like our first fraction that we wrote, our first multiplication, because the x's on the top and bottom will cancel each other out. And we put one in the middle. How can we evaluate that?
Put the 2 lines together.
Like y squared?
No, I just put them together so you can put them down.
No. We're not adding, we're multiplying.
The y over one.
Okay, because something on its own is like a fraction with it over 1. Now what can we do? Looking back to this, what can we do now? We've got a y on the top and the y on the bottom, right? What do those do to each other? They can't. We cross them out. Y on the top and y on the bottom can't cancel each other out. So on top we've just got our left with a y, or a 1, sorry. 1 times 1a, which we'd usually just write a, but we could write 1a. 1 times 2, we get a over 2. The rest of the stuff cancels out. This one I'm going to have you multiply, so we'll pause the video here. What can we cross out on this? Leah?
The A's.
The A's for sure, because we have an A on the bottom and an A on the top. Anything else? All of them? We would leave the 3 for sure. But the question is, can we cancel all of the M's? I see some people shaking their heads, so we need an explanation of why. Then.
Because you can't cancel out the 3 and
Why not?
it's on the top. And so
But we have an M down here.
But that one gets canceled out with 1 that's on the list.
It doesn't really matter which one we're doing, but I think you're thinking right. We've got 2 M's on top, 1 on the bottom. We can only cancel out equal numbers. So this would be an M times an M over an M, but that means we can only get 2 of them. We could cross that one out and leave this one. It wouldn't matter which one we get. But we can only cross out one of them, and then we can multiply across. So this becomes a 1, so 1 times 3M. So we still have that M up on top. 1 times 2 times 7 is 14. So we'd write it out 3M over 14. But as long as we have 1 for 1 on the top and the bottom, we can cancel those out. So rule 2 here says that variables or numbers on the top and the bottom of multiplied fractions will cancel each other out. So whether it's the number 7 or the letter M or A, if they're on both the top and the bottom, they will cancel each other, equal numbers of each. Okay, so let's multiply some of these and simplify them. What can we cross out on these two? The CM. Now it's important, we couldn't cross out just the M with these, because now we're talking about units. So the CM is centimeters, and centimeters we can cross out, meaning that we would get 1 times 1 meter over 100. So it'd be 1 over 100 meter, or since we'll want to start dividing them out, 0.01 meter. I can't easily erase in PowerPoint, so we're just gonna have to get that up there. Okay, what can we cross out in this example? What is that thing, David? Centimeters and meters, you got it, because centimeters go with centimeters. Meters go with meters. What is this thing again? We talked about that a week or so ago. I've got a sign of it up above. It's mu, the sound a kitten makes. It's micrometers. So we get 5 times 1 million divided by 100. That'd be 50,000 once we divide those out. We'll practice doing the division and multiplication. And the only units that are left are those micrometers. So it'd be 5 million on top divided by 100 gives us 50,000. One more on this page. Give that one a go on your own. See what your final answer is. So I see a lot around the room that, okay, we've got a meter here, we've got a meter there, so those can cancel. Also, since we have bottom and top with seconds, seconds and seconds can cancel. They don't have to be next to each other. When we divide these out, we get 18,000 on the top, 1 on the bottom, and then the units, we've got centimeters on top, minutes on the bottom. Well, now we wouldn't report the whole answer like this, because we can't report anything, especially on the computer, as a fraction. So, I'll write over here. The way we report this, we divide out the numbers. So 18,000 divided by 1 is obviously 18,000. And then the units we put more or less side by side. It's the typical way to write them with a sideways slash in between. And we'd read that centimeters per minute. So we converted 3 meters per second into centimeters per minute. The numbers aren't different. They're actually the same number. It's just a different way to express it. And since we're on the topic of expressing things in different numbers, let's practice this. I'd like you to give me a couple different ways to write the same value, but in a different unit. So 0.25 hours, how much time would that be if we didn't measure it in hours, if we used a different unit of time measurement? So how else could we express 0.25 hours, a quarter of an hour?
1/4.
But that's still in hours. So if we didn't use hours, so how many minutes would it be?
60.
It'd be
Oh, never mind.
a quarter of it.
15.
15 minutes would be one way. Okay, what would another way to express that be? How many seconds would it be? This is real time, I'm not slowing it down or anything. 900 seconds if we just multiply by 60. But all three of those things have the same meaning. They are all the same amount of time. It's just different ways to express it. And so the number changes quite a bit, but the amount of time, the measurement, doesn't change. Oh, 1.5 meters. How else could we write that? Changing the units, but keeping the length the same. Nope. Because a meter is not 3 feet. A yard is 3 feet. So we couldn't change it into feet as quickly as that. We could change it into feet. I don't know what it would be. Let's focus on a little easier ones for us. How about, we should be able to convert into centimeters and millimeters and maybe even kilometers pretty easily. How many centimeters would it be? Everybody should know this when we took our metric system quiz last week and did as a class very well. What does centi mean? Maddie. You came up with that answer pretty quickly. It seems like you could have volunteered it earlier. Yeah. Good, yeah, they're 100 centimeters in a meter, so 1.5 meters would be 1.5 times that, 150 centimeters. How about millimeters? Milli means what? Yeah.
1,500.
1,500. Milli means 1/1,000, so there'd be 1,000 per meter. Can't erase that. Okay, kilometers. Now, kilometers are big. We have to divide by 1,000 to get it. So it'd be 0.0015 kilometers. Different numbers, all meaning the same distance, the same length of something. 12 grams. So our important rule 3 said there are multiple ways to write a measurement without changing its value. So we also did 12 grams is equal to 0.012 kilograms. And it's also equal to 12,000 milligrams. Just converting those units. I think for tomorrow, I'm going to assign some homework here. So our next slide is just going to have some measurements that I want you to do something similar on. Maybe not. Maybe we don't have to. Let's see. We're going to be using something called conversion factors that are fractions that show these relationships. We already talked about the fact that there are 1,000 grams in a kilogram and that there are 1,000 milligrams in a gram. We're just going to be representing those conversion factors as fractions. So, for example, 60 seconds over a minute. Those two are the same. Okay. Or 1 meter, or 1,000 millimeters, or 12 inches in a foot, or 1,000 grams in a kilogram. Those fractions, each of those fractions has the same value on the top as it does on the bottom, which means...
May I have your attention, please? At this time, 9th graders who are scheduled to receive flu vaccine.
Each of these fractions has the same value on the top as it does on the bottom. What does that make it equal to if it's got the same value on the top and bottom? 1. Each of these is equal to 1. We just wrote the values differently, but they're the same values top and bottom. What happens if we multiply something by any of these fractions? They stay the same. They might look different because 60 seconds looks different than 1 minute, but they will be the same because we're just multiplying by 1. We're going to pick up there tomorrow and actually put this into conversion work, but keep that in mind.